Hydrates and acetals. When water molecule gets added to aldehydes and ketones, what it forms is hydrate. A hydrate is a molecule where there are two OH groups attached to the same carbon. And therefore, this can also be called as gem diol. Say, for example, when you have two chlorines or two halogens attached to the same carbon, we will call this as geminal dihalide. And therefore, this molecule, which has two OH groups attached to the same carbon, can be called as geminal diol or gem diol simply. For this reaction to occur, we need to have acid catalyst because water is a poor nucleophile and the reaction without the catalyst is going to be slow. Since we are adding acid catalyst, the first step in this reaction is going to be protonation of this oxygen. So water is going to stay as hydronium ion. So let's write that. So this oxygen with its lone pair of electrons is going to go grab one of the hydrogens from the hydronium ion, thrust these electrons onto oxygen to neutralize that positive charge. And it's going to give us the protonated carbonyl species. And in the next step is where the water will go and attack the carbonyl carbon. Okay. The water will go and attack the carbonyl carbon and thrust these electrons onto oxygen to neutralize the positive charge on oxygen. Okay, and this protonated tetrahedral intermediate will again lose a proton, will get reprotonated to form the hydrate. So there will be another water molecule which comes and grabs this hydrogen to neutralize this positive charge on it. So now we will be having the hydrate. Like water, alcohols can also add to aldehydes and ketones, but the product obtained is going to depend on the number of equivalents of alcohol added. With one equivalent of alcohol, it's going to give us hemiacetal, and with two equivalents of the alcohol, it's going to give us acetal. Like water, alcohol is also poor nucleophile, and therefore this reaction needs to be catalyzed in the presence of catalyzed by an acid. The meaning for hemi in Greek is half. This product, hemiacetal, which is obtained by reacting the aldehyde or ketone with one equivalent of alcohol, is halfway to the final product, acetal, which is formed by reacting with the second equivalent of alcohol. If we use ketone as the starting material, these two products right here can be more specifically called as hemiketal and ketal respectively. Let's now take a look into the mechanism for the acid catalyzed acetal formation. First, to begin with, the aldehyde or the ketone that we use is going to get protonated. So here is our ketone. In the presence of the acid, this oxygen is going to get protonated. Now in the next step, the first equivalent of alcohol is going to react as a nucleophile, attacking the electrophilic carbon. Now in the next step, a base comes and abstracts this proton and neutralizes the positive charge on oxygen. This is going to result in hemiacetal. So this structure right here is hemiacetal. Of course, you can also call this as hemiketal since we started with a ketone. Now here we do have two groups which have exactly the same basicity, right? Both of these can get protonated. Let's say the OH is going to get protonated, in which case it's going to lead to the formation of a protonated tetrahedral intermediate. Let's draw the structure for it. So here is the protonated tetrahedral intermediate. Now these electrons that are present on this oxygen is going to thrust in to form the double bond and kick out the water molecule. So water molecule is going to get eliminated at this stage. And this will result in an O-alkylated intermediate. Here is our O-alkylated intermediate, which is a very reactive species because it has got a positive charge on this oxygen. Okay, and in the next step, another equivalent of alcohol will go and make a nucleophilic attack on this electrophilic carbon. This carbon is even more electrophilic now because of this positive charge on oxygen. Let's say that it reacts with another equivalent of methanol. So now it goes and attacks, make a nucleophilic attack on this. These electrons will be thrusted onto oxygen. Now it had formed a protonated ketal. This one right here is a protonated ketal, And in the next step, a base comes and abstracts this hydrogen and neutralizes this positive charge on oxygen to give the final compound, which is the ketone. Now, we might be thinking that this is an unstable compound because we do have an sp3 carbon which is attached to two electronegative atoms, right? But acetals and ketones are stable molecules and can be isolated if the water that is eliminated from the reaction is removed from the reaction mixture. Let's say that you don't remove the water molecules from the reaction mixture, then in that case it's going to give us the aldehydes or the ketones that we started from.